We're very excited to introduce the Solion XP here at the EU PVSEC. The Solion XP is introducing two new critical features that we believe the industry needs. One, it has advanced patterning capabilities. So the ability to dope wafers in with precise features with very good precision and repeatability. The second is to be able to do this at very, very high throughput. By having a multiple scan system and to be able to do this at 3,000 wafers per hour, it gives us throughput and gives us the precision and repeatability that's going to be required in the future for advanced cell designs. We found that the uniformity across the wafer and wafer to wafer has a big impact on the final cell binning at the end of the line, and that the uniformity, repeatability is critical factors in the emitter design for giving much tighter binning control. The way that we do it is we measure the beam current, we then scan the wafer through the beam, we measure the beam current again, and adjust the speed of the scan rate based upon what dose and what the beam conditions are, so that we can precisely implant an exact dose across the wafer and wafer to wafer. So we call that closed loop dose control, where there's metrology measuring the beam current, and that's fed back into the scanning system to ensure repeatability. We go beyond that, though, with the XP. So we not only measure the beam current, but we measure the constituents of the beam. So we actually have a mass spectrometer that's looking at the components in the beam, so that if there's any difference in the components of the beam, that would affect the dosimetry on the wafer, and we can account for that or at least alarm and alert the manufacturer that something's changed in the dosimetry system. So when we designed the Solion XP, we designed a platform that we knew and wanted to be used for today's PERC designs and future designs using N-type wafers. So that would be PERT designs, Pearl designs, and eventually we believe IBC. What's critical for some of these advanced designs is patterning capability and the ability to do boron doping. And so that was very important for us to design that into the tool right from the start, because these are capabilities that would be very difficult to add later on. We've published and seen results, PERC designs using ion implantation above 20%. We've published results using PERT designs of coming close to 21%. We think an N-cell Pearl design can be over 21% in cell efficiency. And certainly IBC cell designs, we've published over 22% and believe the entitlement is up to 23%. So it's very exciting for us in terms of having an extendable platform that can be used today and then can be used in future high efficiency cell designs as well. It's single-sided doping. So in these advanced designs where you have to dope both sides of the wafer, we don't have to add additional masking steps. In some of these, in the Pearl and IBC designs, you want to do pattern doping. That's a significant reduction in terms of processing steps. Pattern implantation can achieve some of these advanced designs without adding a lot of steps, and that's very important in terms of getting high cell efficiencies without adding cost to the wafer.